Hello and welcome back everyone. We're going to be looking at chapter 5, which is chemical equations. And I'd like to go ahead and show you a chemical reaction. So over here on the right hand side, we have hydrogen and oxygen, and they're going to react together. And when they react, they make water. And that sounds kind of boring, but check out this chemical reaction. It's pretty fun.
As the oxygen flow is increased, the explosions become even louder. This shows that the ratio of hydrogen to oxygen is important in the reaction of hydrogen with oxygen. When the appropriate ratio is obtained, relatively loud explosions are heard.
So isn't that amazing? Those enormously loud explosions there are the reactions between hydrogen and oxygen. And we can write a chemical equation for this reaction. So the reaction is actually what actually happens, but we can write a symbolic equation called a chemical equation. And we got a couple of different ways to do this, right? So we can actually write what's called a word equation. So we can write hydrogen plus oxygen, and those are reactants, and we draw an arrow when they react and they go to form water. So that's one way we can write this. So that's certainly one possibility. And another way we can write this, we can turn it into a word equation, and a chemical equation, and we can write the symbols here. So hydrogen is a diatomic gas, so that means it's a molecule made out of two atoms. And oxygen is also diatomic, so we can write O2, and then it forms water, whose formula is H2O. And just some terminology here. I think we've mentioned this before, but the left-hand side, these are called the reactants, so these are the things that come together. And the right-hand side, this is called the product side. Here, there's just one product, but we'll see in a minute, there's actually two water molecules. And then the arrow here represents the yield, so they alter now and they form the product, so that's typically pronounced yields. Now if we go ahead and we draw sort of a molecular symbol kind of for this, right, the hydrogen is a diatomic, so we can go ahead and write a couple of little H's like that, and then the oxygen, it looks something like that, and then the water looks something like this. And you can immediately see the problem here, I hope. And the problem is that we violated something called conservation of mass. So if you look at your two hydrogens on the left, they are represented on the right, but there's only one oxygen on the right, and there's two on the left. So clearly we've lost an oxygen here. And so how do we accommodate that? So how do we actually deal with that? Well, one way we can come up with this extra oxygen is to write another water on the right-hand side. And so another water then would have that second oxygen. But of course, that's just shifted the problem to something else. Now we've got four hydrogens, and we've only got two. So another way to do this, right, is to say, well, maybe we start with two hydrogen molecules. And this is actually a proper equation now. We call this a balanced chemical equation because both sides would weigh the same. They would be perfectly balanced out. We've got 1, 2, 3, 4 hydrogens here. We've got 1, 2, 3, 4 here. We've got two oxygens here, and we've got two oxygens here. And the way we represent that in our chemical equation is we use a coefficient. So a coefficient is a number we write in front of the formula. And in this case here, there's two hydrogens. There's one oxygen. We can write a 1 in, or we can actually ignore it. It's completely up to you. So I'm going to go ahead and erase it. We normally always ignore it unless we're trying to make a point. But we can go ahead and write the coefficient of 2 in front of the water. So now we've got a balanced chemical equation here. We can go ahead and balance some more chemical equations. So for instance, if you've used the Bunsen burner in the lab, the Bunsen burner contains methane, that is CH4, and it burns, it reacts with oxygen in the air and turns into carbon dioxide and water. And so we can look at this equation here and we can balance this equation. And an easy way to do it is underneath the reactant and underneath the product side is just to count up the number of atoms of each element. So there's one carbon here, so we can go ahead and put a 1 here. There are 4 hydrogens, so we can put a 4 down here. And there are 2 oxygens, so we can put a 2 down here. And if we look at the right-hand side, we've only got 1 carbon, so again, we put a 1 here. We've got 2 hydrogens coming from the water. And the oxygen's the tricky part because we've got 2 oxygens here, and we've got 1 oxygen here. So that's a grand total of 3. Sometimes it's a little hard when we've got the same atom of the same element in 2 different things. So we have to remember to look in all the places. So there's 2 here and there's 1 over here. And the carbons are balanced actually, but the hydrogens and the oxygens are not. So we can balance the equation by changing coefficients. So that is, we can put numbers in front. Now you might say, well, actually I could balance the hydrogens quite easily. I could take my eraser and I could take that H2O and maybe I could change it to an H4O. And at this point here, it would now balance right? We would change our number of hydrogens from 2 to 4, but we're not allowed to do that. And why don't you think we're allowed to do that? That's right, because now it is no longer water. We've changed it to something completely different. So it would be really nice if we could kind of reach in and we could alter the formulas, right? If we could play chemistry god, but we are not permitted to. So we're not permitted to change it from water. So what we have to do is we have to change coefficients. So if we put a 2 here, that reminds us that there's now 2 of everything inside that box. So water has 2 hydrogens, so now we've got 2 boxes, so that's 4. And water has 1 oxygen, so now we've got 2 of them, so it's got 2. But remember that we also had 2 over here, so that gives us our change in oxygen now to 4. And the carbons and hydrogens are now balanced, but the oxygens are not. And again, we've got too many on the right. We've got 4 oxygens on the right. We've only got 2 on the left. And so where does oxygen come from? It comes from just O2. So in order to balance that out, we have to put a coefficient of 2 in front of here, and that changes that 2 to a 4. And remember that, why didn't we go ahead and put a 1 in front of here and increase it by 1? Well, actually, there was already a 1 written there. We don't write the 1 out normally, but it's inferred, it's implied to be there. So we went from 1 to 2, and that gave us from 2 to 4. And now everything is perfectly equal. There are 2 carbons on each side, 1 carbon on each side, 4 hydrogens on each side, and 2 oxygens on each side. So we've got a balanced chemical equation. All right, so here's a chemical equation for you to try. So C3H8 is propane. If you've ever grilled outside with a gas grill, this is what you're using. It reacts with oxygen from the air, and it combusts, and it forms carbon dioxide and water vapor. So I haven't put any state symbols in here, but we could if we wanted to. It doesn't change the balancing. So, maybe the water vapor, right, is a gas, CO2 is a gas, the oxygen is a gas, and the propane itself is a gas. So there we go. Doesn't affect the balancing, but can you go ahead and change the coefficients and balance that out? And go ahead and pause the video and have a go, and we'll come back in a minute and look at it together. All right, so if you've tried, then the easiest way to start is to just look at each element. We've got carbon, hydrogen, and oxygen. The order you do it in, it doesn't really matter, although actually it's almost always easier if you do it C before H before O. And initially there's 3 carbons on the left and there's only 1 on the right, so we can see it's definitely not balanced. There's 8 hydrogens on the left and there's 2 on the right. And there's 2 oxygens on the left, and there's 3 on the right. Remember, there's 1 from the water, and there's 2 from the carbon dioxide. So we can fix the carbon by putting a coefficient. If we put a 3 in front of here, that changes that 1 to a 3, but it also changes the oxygen. So we've got 1 from our water. Our CO2 had 2 in each, and now we got 3 of them, so we got a total of 6 oxygens here, plus the 1 here. That makes it a grand total of 7. So see how changing 1 coefficient actually leads to a change in 2 different atoms there below. All right, so our carbons are balanced, so we can look at our hydrogens. So the left-hand side has got 8. The right-hand side doesn't have enough. It only has 2. But since there's 2 inside of every water, if we have 4 waters, that would give us a total of 8. So we got 4 twin packs of hydrogen there. And of course, that doesn't just change the hydrogen, it changes the oxygen. We can see that we've got 3 times 2, there's 6 oxygens from the CO2. And we got 4 times 1, there's 4 oxygens from the water. 6 and 4 make 10. So we've got one more thing here. We've got 10 oxygens on the right. We need 10 on the left. Since they come in pairs, then we need to change the coefficient in front of the oxygen to a 5, and that makes it now 10 oxygens on each side. So we've got a balanced chemical equation.